Hi, everyone. I'm Nimbus. I work at Demandbase, where we do kind of account-based marketing platform, so kind of B2B marketing and kind of helping people achieve that through the use of a lot of data. Kind of working on these things over time, you want to have kind of production quality in them, and I'm going to be talking about what does that actually mean. These days are very exciting times. There's all sorts of tools and wonderful open source ecosystems available to us that we can start, putting things together. There's people follow the creative process, starting with some piece of data, working with it in a system, adding some more data, adding some more systems. Sometimes it gets a little crazy. You've got some big ask. It's like, we need this and this and this. Can't you just throw it together? It's just going to be a quick little proof of concept. We're just going to see how it goes, and you wind up with some kind of product out of this. And it's beautiful, it's lovely, it's the product of your creative effort. And then something happens where someone like this guy is going to tell you, hey, let's put this in the app. It's going to be great. People are going to love it. Now, one of the things that comes with is the ability to do this again in the future. So the first time you did it, it worked out fine. But then when you go and repeat the process, you've got new data coming in, you've kind of fixed things that were kind of not quite right before, and you have things changing over time. And this is often good. We want things to change over time. We want to take in new data. We want to fix things that were wrong before. However, sometimes just changing things is going to cause problems for your consumers, because they're like, whoa, how could this change? I don't want this to change. And now this guy comes back to you again and says, well, we got to work on this. We got to productionize this system. It's we got to get it out of dev and harden it. And so I'm going to be talking about what does that mean? And there's all sorts of happy adjectives that people throw around that end in ilty. These are all good things. But there's a plethora of these things. And how do we know what they mean or what to focus on? So I'm going to be trying to focus it down a little bit to try to get to the things that, at least for me, these are kind of things I worry about, things that I get headaches about, thinking, am I going to have to worry about this, or is this going to be fine? So I'm breaking it down into three areas. One is kind of consistency in your results over time. The actual product, the results you're developing, the data set itself, what you're delivering to people. The other is the speed and convenience of your own development. How is your tooling working? How are you writing this, and how are you developing it kind of before it gets to anyone else? And then the way you're delivering things. So the safety and frequency in your delivery itself. So how are you deploying this? How are people consuming it? How are you switching from one version to the next? So these are the three broad categories that I'm going to be talking about. And let's just jump into it. So now, what are some of the things so mainly what I'm identifying is here are common issues that you might run into these categories. And obviously, I'm not covering everything. This is only a 20-minute talk. But I'm going to cover a few of the kind of top items that I consider when I'm thinking about these. So one of the main things that you can consider in your kind of consistency of your results over time is, are you missing records from one thing to the next? And this, depending on what kind of system you're working with, this may be a bigger or smaller problem, or not a problem at all. The other is kind of like, oh no, we've kind of made this thing, and sometimes if you have an accounting system or something, it needs to be 100% rather of every time, or else it's wrong. But if you have something that's more fuzzy, it's like, oh, we want this to be accurate, but we're not expecting 99% accurate. That's still some things wrong, and maybe from one to the next you have a regression in quality. Or we have things that just literally cause things to break between your consumers because you have kind of different schema than you had before. Now, there's also issues that occur when you're developing things. So kind of broadly, there's kind of, if you have bug reports and kind of issues that are brought up, how are you going to track that down? Sometimes that is very difficult. And sometimes when you go and want to make changes, it can be very difficult to see these changes out depending on what you've got going on in your system. And often, these systems can be very slow to see new results. So, and when it comes to delivery, kind of main two topics in that is it can be these batch processing systems. They're not super fast, and sometimes you want them to get results on a quicker basis. So that's one topic. The other topic within that is sometimes there's inconsistencies in the way you're rolling this out, and there are any number of things that can go wrong, and I'll be talking about a couple of them. So now let's talk about actually addressing some of these problems. So first, when it comes to missing records, so imagine you have a system like, say, a company database. Companies kind of come and go, and you might have, kind of, depending on the way you're producing it, you might have kind of some of them in there from one thing, and then you use perhaps different data or perhaps different logic, and somehow not everything in there that was there before is still there. And that might cause problems for some of your consumers, depending on how they're using them in, say, an application. So one of the reasons why you might kind of lose records from one version to the next is that you might be depending on data that's changing over time. You might be working with another data set as well, like one of your sources, which kind of itself comes in versions, and as it changes over time, and it might not have what it had before, you're not going to have it either. So one way that you might address this is to try to stick to append-only data sources. That is, keep everything in your full history and always take it in over time. Only add data into the pile. Don't remove it. Of course, if you're in a situation where this is, you don't have this, you're depending on a database which is getting updated and deleted, and it depends on how much you care about losing records over time. If you do care, you might have to actually start storing each version of the database as you take it in over your own versions. Other strategies include kind of introducing a different sort of contract with your consumers. So for good reasons, you might have things that falling out of your data set that you want to fall out of your data set because it's like, oh, this is now inactive and we want to treat it as such. But so that things might break, you might include them but mark them as inactive. In other things, sometimes things, kind of the identity of them merges together. So you might define like an aliasing system. You would define like this ID now points to this other ID, and it's OK. So that instead of like throwing things out that you had before, you kind of either declare them inactive or you alias them to another identifier. Another topic is kind of validating your results. So if you're kind of trying to make an effort to kind of verify your results and make them, kind of guarantee them to your consumers in a better way, your validation itself might rival the complexity of your actual build process, and this is a good thing. There's all kinds of things that you can check, and like whatever kind of assumptions you make, you want to carry them out. And I think an especially important area is to just diff your versions and see what comes out of that. And that can be challenging because like obviously you want it to change, and sometimes the way, but so you're not trying to say like this should be exactly the same over time. You just want to kind of find ways, as many automated ways as you can, in order to see if there's red flags that get raised, so that you can dive in further. So, as an example, like if you just like go off the columns of your data set, you see one kind of easy thing to do is count the number of distinct values, and then see how that changes from one version to the next, and if, like, for some reason there's a drastic change in them, you might say, like, oh no, we should look into that. And often you have to kind of manually observe these things, but the best way to do it is to kind of narrow it down first before you start kind of looking at millions of things, which you can't really do very effectively. So various validations. Not going to go too deeply into any of them, but those are great. So now, when it comes to development and kind of making that, improving that, sometimes these things can be black boxes. These systems don't lend themselves very well all the time to kind of tracing the lineage. So you might have people kind of asking you, hey, this record in your data set that you produced, it came out like this, and I don't understand why. Can you tell me why? And often you can't, or it takes great effort for you to go and explain how something came to be. And it doesn't come, kind of understanding the lineage of the data through your system, it doesn't come for free. You have to often deal with this. So one of the properties that is very helpful for making sure your system is you're able to track these things down is reproducibility. So reproducibility is the idea that with the same inputs, the same parameters, you're able to produce the same output. And that for a lot of these systems, you don't have that by default. And if you're not checking that you have this, there's a good chance you don't. So there's different ways that you can have systems that aren't reproducible. One, obviously if your logic is non-deterministic, which in a lot of these big data systems can easily creep in because of how things get ordered differently from the shuffle, and then what you do after that point. And if, so obviously the best way to do this is to just check, do multiple runs on these things and see that when they should come out the same, they actually do. And you might sometimes be surprised that they don't. So the other thing is your input data can be changing over time. Right? And this is a good thing. This is how it works. But so something you might consider is introducing in your config, you would say I want a high watermark so that I only want to use the input data up to this point, as opposed to say use all data, including the current data. And if you specify a high watermark, that means if someone asks you about last versions, what happened there, you could actually go and reproduce that with the parameters and have it come out the same so you can isolate these issues. Isolation is a very important topic because if you don't have the reproducibility of your, you won't be able to isolate things very easily. Now, we generally want to fail fast in these systems. When we make changes, when we have new data, we want to know as soon as possible whether it's going to break or not. And there's a whole sort of range here from kind of the worst situation to the best. So the worst is you don't know if it's wrong or not. It just looked fine, and you don't find out that something's wrong until someone that depends on it complains to you about it. And that's kind of the kind of very slow sort of testing framework. A better approach is to get as much kind of if you get a compile failure because you're accessing a field that doesn't exist anymore, or you have a schema mismatch. Often you can detect that at compile time, and that's really what you want. You want to arrange your system so that it's as front-loaded as possible, where it'll fail if one of your assumptions is wrong. And there's all sorts of things in between. Generally, recommended test on your full data set, see what comes out before you kind of merge new logic or new data into production. And now development can be very slow. And one of the common strategies to speeding up that process is to actually cache things and use intermediate data. You might split up your logic instead of having one big black box, you have stages along the way that you can save and kind of run independently. And then that allows you to iterate more quickly, because it's maybe the first stage is pretty slow and you're not changing it, but you're working on a later stage and you want to work off of that. However, there are some dangers that can come along with this. One is that if you have these different systems that are kind of writing out and reading back in, you might lose compile time checks, depending on how you're defining your schema. So if you're using Spark with data frames, you write out data frames and you read it in back later and cast as a data set, you could have schema mismatches between your two runtimes, and you then lose that property that we want of failing fast to kind of catch some of these things at compile time. So generally, I recommend approaches where you maybe don't split, you still kind of maintain as few systems as possible. but you use perhaps get or create patterns so that you can get the benefits of kind of speeding up with intermediate data. You have cached data, but you're still keeping things within one system. You can have like a type checked system all the way through, and that's usually a kind of a plus. So now talking about issues you might encounter in delivery and how to deal with them. Deployments are very difficult, and I would say generally when you start with kind of, I've made this data set, now I'm deploying it to consumers, it's not a simple process sometimes, especially if you have multiple consumers or if you're delivering to multiple systems, and especially if there's multiple people involved with multiple buttons that have to be pushed in a synchronous order. And the kind of more people involved, the more buttons involved, the more systems you're deploying to, the greater number of things that can go wrong. Or you can have things where you partially deploy it to one but not the other, and then there's an inconsistency and people are upset. So the ideal is to get to an arrangement where your deployments are atomic. That is, there's one button that one person can press that it switches from one version to the new version. And this is easier said than done. And I can't really go into how you achieve this in practice, but an example of this would be like if you have a new version of a table in a database, doing just a rename, assuming everyone's depending on just that one database. That's an example of like an atomic deployment. Another example is if you have, like, say, you have a route to a database instance that is defined and everyone's pointing at that route. And then you bring up a new instance and you switch, and it becomes ready, and then you hot swap, you switch the route to the other thing, and that's generally good practice. But easier said than done. Some of these, and generally, if you can work to get fewer buttons and fewer people involved, so that there's less things that can go, less chance of a partial success in your deployment, that would be best. So now about item potency. So when we're deploying things, we're delivering things together, we're carrying out these operations, there's failures that happen, and we want to deal with them gracefully. So say you're writing to a database system, and you have some process that's doing inserts, and it fails halfway through. Now you have a bunch of records. Now if you have half your records there, and how are you going to repeat that? If you go and repeat that process and it succeeds the next time, you still have a problem, because now you have all the data that you want, but then you have duplicates of about half of it, which is not what we want. So it's best if you kind of use operations that are item potent. That is, if we have failure or partial success, we can simply retry the operation and reach, we reach the desired state at the end. And so this needs to be resilient so that it can be run multiple times. So if you had a failure and you retried it, you can reach a success. And also, if you had a success and you try it again, you still have a success. That's the principle of item potency, and it's something you probably want. So, kind of examples of, say, if you go kind of like database operations, inserts and appends are not item potent if that's all you're doing. Overwrites are. However, overwrites can possibly lead to other problems, such as, hey, why did you delete all the data and then leave this period of time where I didn't have the things I had before you inserted the new version? That's unhappy as well. Upserts for databases tend to be kind of for like if you're kind of deploying data to an active system and you're trying not to screw it up, that's generally the thing you would want to do. But it's obviously it's kind of a little more complicated to deploy sometimes. Now, if you're worrying about kind of getting results to people faster, if one of your problems is your batch is too slow, we need more frequent updates. Something you might consider is deploying what people kind of have termed a Lambda architecture. And the thing is you probably don't want to do this unless it's really important that you get those updates out quickly, because it's very expensive and complicated in order to deploy a system like this. And what it is you're duplicating your input data when it comes in. It's going to two places. One, it's going to your warehouse where your batch layer will be able to pick it up. And it's also going to your speed layer, which kind of makes inserts data, kind of makes updates live in the serving layer. But then periodically, your batch layer is going to be basically kind of defining the kind of the solid truth over time, and it needs to kind of play nicely with the speed layer. They both need to play nicely with each other. So accomplishing this is really going to depend on your ability to be successful in the other topics that I mentioned. And so now, what are couple takeaways? I generally think that a suffering-based approach when it comes to these things is best. We don't really want to bust your ass to do any of these things unless you have really good reason to. So addressing the underlying issues that are causing pain is generally what I think you should do. And it's best to, kind of an ounce of prevention is worth a pound of cure. That is, if you kind of think about these things ahead of time before you've gone and deployed these things, you understand the risks you're going to have, that's usually best rather than trying to go and realizing it after the fact and changing everything. That can be much more painful. And that's it. Does anyone have any questions?
You talked about atomic deployments.
Yeah.
I was wondering, that kind of where it becomes even more difficult when you want your deployment to be continuous and automated. So I was wondering, what are there any frameworks, CD frameworks, CM frameworks that you would recommend?
Oh, as far as like continuous atomic deployments, I mean, there's no reason you can't use tradition. I don't have any special recommendations aside from existing things. There's no reason you can't do continuous integration with atomic deployments with something like Jenkins or TeamCity. It's just a matter of like what are the operations that's actually doing that determines whether it's atomic or not. So no special answers there other than existing.
On the same topic, when you're looking at doing an atomic deployment like this, was essentially like a blue green replica where you're essentially standing up a second stack, a second database, and then flipping over a route to the different. When you're dealing with a database, standing up an entire new database can be expensive, but it's also expensive in time.
Yeah.
So I want to replicate my registered database over, which is like terabytes. It's going to take time to stand that up, and so then you can.
Yeah,
the automaticity of it is, well, you can get it, but then basically need to shut off all of your processing for hours while that's going.
Yeah. So this is the last question because I'm out of time. But so the question was like, what do these systems? If you're trying to do a hot swap or you bring up an entire new database and switch it over, some of these things that's going to be very expensive both in time and money. And if that's when that's the case, I would say this is a balance of like you want to go with something that's going to be reasonably priced and like effective and simple and work for you. And I'd say in that case, stick to upserts. If it's kind of prohibitive to be standing up new things, then don't. You kind of have to bite the bullet and do the hard stuff with appropriate upserts. All right. Thanks everyone.